topic is about process management. In process management, we will discuss about program, process, and threads. So, what is a program? Program is basically an executable code that could reside on hard disk, your floppy drive, your pen drive, or somewhere in residual form, or even in memory while you are writing a code. So program is basically an executable code that is a passive entity. Okay. So when we refer the term program, we basically refer the term as a conceptual work. Okay. That can be executed on the central processing unit. So that is not currently running on the CPU, while it can run on the central processing unit and perform some tasks. That is a program. Now, the term process refers when a program comes into a state of execution. So, what is state of execution? State of execution when a program is scheduled to run on central processing unit, and even the program has got the timer waiting, got the timer for running on the central processing unit, and after that it may be in running state, waiting state, then running state, waiting state, etc., etc., and then it go into termination state. Okay. There are more states we will discuss later about the process states. So as you understand that a process is a activate entity. Now a process has associated resources. There could be virtual memory, open files, associated users and user groups. Uh, a process can create children's, even it can create threads, etc., etc. So it has a lot of resources associated with it. Uh, in kernel process management, process has process ID, process stack, process heap, process memory as virtual memory have been discussed, the CPU time, and etc., etc., lot of information. So all related information is stored in process control block that operating system manages. In core kernel of the operating system, this information is stored. Process ID, stack, heap, memory, CPU time, etc., etc. Now process can be created using fork system call, and whenever a fork is created, basically a parent and child relationship created, and with the fork what happens, basically there are two process created, but they share the memory. They have different process ID, stack, heap, but they share the same memory. So if we want to replace another process with some another task and to upload something, we have to execute exec family of calls. So there are many calls. Let's discuss about some calls. Execl. So this call basically lists all the processes that has to be executed. Exec LP, basically it is similar to list, but it searches for the full path given. Exec VP is V stands for vector, L stands for list. So process can be listed form or on the vector form. Uh, so P stands similarly for full path. So every process name searched in the entire full path as given. exec v, it searches the simple exec.cl and exec.c we call such as files or processes within the um, current directory, while with the p command it searches in the full path. Now, as we understood about fork and exec family system calls, let's understand the process relationship in an operating system. So basically, the first process is the root process. We call it init process. So it has PID one. So whenever operating system boots up, it starts the first process, that is the init process in an operating system that has process ID 1, and there is a PID 0 for idle process. So when nothing is running on the CPU, the idle process runs on the CPU. So that has process ID of 0. Uh, Now, whenever a process is created, whenever any process is created in user land, so that uh, inherits the property of its parent. So every process created under init process. So init process is the parent or root parent of all the processes in operating system. What does it mean? Like you can say there is a God, okay, and God has created everything, so God is our parent, okay, and everything is created underline of it. So similarly here, init process acts as a God, and every process created under init process. So first init process is created by the operating system, then every other process is created. Okay, so that is uh, process for you. Now there is one more thing. Every process has process group. So every process is associated also with process group. Uh, for that, we will discuss about process control block, and in process control block, we will see what is process group and all other details. There are almost 99 fields, 100 fields in process control block, and I think it would be challenge for me to make such video to cover all these details. Although we can structurize this and understand it in group wise. So 99 fields can be grouped into 13 or 14 categories. And let's understand those 14 categories in further videos about process control block. Now let's understand threads. So as we have seen with the fork, a process can create another process. So that stands a parent and child relationship. So when a parent and child relationship exists, so process ID, stack, heap, and memory can be different from one process to another process. It depends if exec is called or not. Um, while what happens with threads, uh, threads are handled through uh, libraries. So basically, there are some libraries written for handling threads. So they work within a process. Process is the basically parent, and threads are their children. But threads are managed through libraries, while fork system call is called, then process is managed through operating system. So that is a little bit difference here. So you have to include those libraries while creating threads. So there are POSIX threads, there are um, another version of thread. I forgot the name. Anyway, so let's understand about threads. What are threads? So perhaps you get the idea that is a small unit within a process. We can say threads are a small unit within a process. So like process ID, every thread has thread ID and local stack. So whenever any small unit runs, so it creates an stack. So that is just separate from the parent process. Now, whatever the heap has to be used, it uses from the parent. So, as you could understand, if you have to share data between parent and thread, then you can utilize heap and memory. So, threads basically uses the same memory area as the parent of as parent process. So, parent process memory is utilized in thread. So, threads have the same memory